This session is going to be mostly focused on Java migration in concept, but mostly about how agentic coding can help you deal with your maintenance problems or kind of upgrade problems going forward. I am Mahdi. I am with Oracle Code Assist team, which is a part of Oracle Cloud Infrastructure. And I've been with the AI/ML organization and Oracle Code Assist for about 2 years, building coding assistants internally. This talk is going to be a partnership between us, and we are blessed to have Saoud here, who is CEO of the Cline, which is a very prominent open source coding agent. The way that we have mic'd up, I was thinking that we are going to go around and kind of like have the full stage, but that's why when he gets here, you will see him in the shot as well. So without further ado, let's quickly get started. So the most important part is that why this even matters. Fundamentally, with coding agents, upgrading Java or any of your really supply chain of code is not really optional. You could think about should you upgrade or not, like legacy code and stuff like that. But if the cost of doing this is relatively minimal and the performance gains are there, why should you not be doing that? Fundamentally, there is a risk, of course, to having older versions of JDK. There is, of course, performance left on the table. You are here in this JavaOne to learn about new versions of Java and how they improve your life. But the key question always is that if I have built a system, these older versions, how much it takes for me to get these benefits that came to me, like virtual threads and other features of the system. Generally speaking, managing different versions of it and living with legacy code in some shape or form is an operational complexity that kind of can bog you down as you go through your journey of writing or maintaining your software stack. Upgrade for Java, and you're in a Java conference, so you're probably already familiar with that. It's just not a maintenance issue. It's not like, well, I'm going to upgrade my dependencies so things don't break or if security vulnerabilities do not exist, and so on. Of course, it improves your security and performance and simplicity, but also adopts the more modern patterns of software development and maintaining. And hopefully that is going to, across the board, improve what your software stack does. Because at the end of the day, every application's job is to deliver some value to your customers, be it, in every sector that you guys live in. And fundamentally, this kind of KTLO aspect of it is going to reduce, long-term technical debt, which if you can pay off, it makes your engineers, frees up your engineers to do more productive or interesting work. Now, why upgrades are typically hard? Because your application is typically not an isolated piece. It's built with a huge ecosystem in which you are operating in. There is breaking changes and unknown risks. There are libraries that you depend on. Last time I checked, for example, Drop Resort has 500 plus dependencies on a bare bones service. That's kind of like a little bit too hard to kind of keep track of. And there are even people who have came up with new platforms just to deal with a number of dependencies, for example, for a project so that you can start with battery batteries included. So dependency frameworks are kind of challenging to keep track of, and it's really hard. And generally speaking, if you have ever ran a kind of Java stack at scale, and I'm from OCI, so OCI runs on Java, and if you're from AWS or Azure might be a little bit mixed, but pretty much every cloud runs on Linux plus Java. I can almost confidently make this a statement. You will see that how much, if you're internal like me, how much of our effort is spent on just keeping the things stable, solid. I can almost tell you that took probably 2 engineering months across the board, the whole engineering, just to be able to move OCI from, let's say, Java 8 to Java 17 or something. I'm not giving you the specifics. I'm just migrating between versions of Java is a massive task, or believed to be a massive task. And now the message of this talk is fundamentally hooked on the fact that if you don't have to do the work, meaning that your engineering team doesn't have to do the work for the most part, wouldn't that be great? You'll be focused on basic your features. And it's not just about getting the code done. It's about, as a leader, and I'm a consulting member of technical staff, so I typically architect this stuff, is that how can I trust how much trust I have that when we are done with it, we are actually 100% done, right? What are the kind of performance like implications that are coming up if I move to virtual threads from my implementation of things to keep my system performant? So what has changed? I'll just give one interesting thing here. People who have heard of Cloud Code, as it has taken the world by storm in some sense, and Cline and other coding agents. Cloud Code specifically is just 1 year old. Saoud is going to talk about how long Cline has existed, but these stuff are so new compared to like the history of Java that we're all here and celebrating, right? That you come to a conference once every year, you might have missed already 5 key events that happened. This is the pace of the industry moving. And so if you have not had experience with AI-assisted development, and I'm not talking about Copilot and autocomplete and things like that, if you still like actually read lines of code that is written by your agent, you probably have to kind of start speeding that up and feeling things going on. So AI-assisted software development is there, and it's not just a helper. It's not an autocomplete. It is way beyond that. It's writing code for you, code that is very consistent. Now, the AI systems are way better at understanding your code bases. And this is without like, fine-tune on my code or training and stuff like that. It is live, like literally happens. You don't have to like do a whole bunch of like pipeline of, bringing your code into like how AI works, similar to traditional machine learning that you might have experience with. The other really interesting aspect of these large language models and their ability that empowers agentic systems is the fact that they can reason about, how things go. As much as as a scientist, we are just basically generating tokens and thinking about it like it's basically generating tokens to think about what is the next thing. Almost like humans, it reasons about the structures that it observes in your code base or systems that you have built in general, and then make decisions based on that, as opposed to is it a standard Java implementation or that? And in other words, there is no decision tree, just like the way that a human reasons about, I see this pattern and I have to adopt to it because some decisions have been made. The same applies. So you don't have to deal with a whole bunch of snowflakes. The system adapts to it. And as Saoud will show you guys, automation of complex workflows. And these are, and I would call them flexible workflows, particularly because you don't have to like, in an old-fashioned thing, you have to regex match and all this stuff and think about all the variations and whatnot. That's just not the thing anymore, pretty much. And that allows us to unlock having more goal-oriented tasks from your AI system rather than trying to railroad it and say, step 1 and step 2, do this, do that, right? You can just basically say, hey, I want test coverage for my system to be like 80%. Figure out which one doesn't have coverage. Is it branch coverage? Is it like method? Don't care. Get it done. Almost like the same way that you're dealing with an engineer. Now, coming back to the Java upgrades and just how to maintain your Java code, there is multiple sources of truth. You're, of course, in this conference, which means that you're very familiar with what JEPs are, right? This is the source of truth. This is how, as a community, we go through the process of what needs to come to Java, how we need to like move forward. And those are the most useful specifications. But not everything is encoded there. In other words, that's the constitution. And there's interpretations and executive orders and all this kind of stuff down the pipe where it basically tells you how to like go about particular things. Java team has fantastic blogs, particularly when there is a new version of Java comes out. There's blog posts of telling you, what are the new things and how you can upgrade from version 1 to version 2. And these are coming from, of course, the experts in the field. And those are kind of plans, but then the plans meet reality of your code base with all the engineering patina baked into it, and then you have to kind of deal with that part of it. But the good part about AI aspect of it is that AI basically reads that, and as we will show you with the skills, it kind of factors that in and then layers it on top of whatever you have. Of course, there's migration guides and whatnot. So all of this complementary knowledge kind of like needs to come to the system, and that's how we kind of show you how we have thought about combining that into a cohesive process, if you will, that we kind of understand. And so this is the kind of high-level framework I put together, basically, is that, number one, we have to combine multiple sources of truth, right? Not all of which can be fit into like one LLM call. And so we have to have a method of how to bring them in. There is, of course, understanding code base and context. Again, not all of them can come in. We have to like basically do context management, which Saoud will talk about. And then apply the correct transformations in the sense that you're going, for example, from like the old Java records to the new version of them if it comes out, or like if you have a multi-threaded system, how you have to adapt to the kind of Loom platform, for example, and so on. And finally, okay, you can edit your code at the end, but will it build? Okay, if it's built, is it actually performing? Or did you actually like, do a transformation that it impacted your performance in a negative way, partly because you did not actually benefit, you used the right patterns to implement things. Some things are fairly straightforward, like, I have a bunch of like if then else, I switch to switch, easy stuff, right? But oftentimes what you're trying to shoot is that it's not just to make it compatible, it's more about actually getting the benefits. The original premise was that you go from one version of Java to the other one, you're gonna get performance benefits. Well, guess what? If your code doesn't benefit from those features or has been implemented in a different way, it might not. As Java is evolving, of course, it's going to be a faster pace of cadence of releases. I would expect this is just like how software world is moving towards. And so you would need to be able to also step up this game of moving and this absorbing this continuous innovation going forward. And of course, as everybody knows, these are cumulative. There is multiple JEPs that you're already familiar with, so I don't kind of like riff on that as much, but there's fundamental things that you may not need to do anything about it, particularly like GC performance and stuff like that. But it's still being able to tune that to your application. That's a non-trivial task. As someone who has worked at OCI, we have spent a good amount of time even opinionating about the way that we have designed our services, which even garbage collector is, for example, a good fit for us. So how does Code Assist, which is an internal tool that Oracle uses for AI-assisted software development works? This is kind of like gives you a mental map. We are model agnostic. We use pretty much every model that helps us achieve our goals. Code Assist basically sits in between. We offer different agentic clients. And we used to have our own traditional non-agentic clients way back in the day when we built it. And Oracle Apps, Fusion, Database, OCI, all of them kind of benefit from this. We kind of unify that platform. There's a lot of governance, as you would imagine, is involved into that. But that's kind of like the mental map of how things work. Particularly a key part of Oracle Code Assist, as Oracle being a relatively large company, is how the license system works, how prompt injection, for example, can come into play, and all sorts of guardrails that come into do it. We used to have our own kind of like models and whatnot, but at this point, I think there are some leading labs that have semi-won that game, so we don't have to reinvent the wheel. So how does Cline come into picture? Well, Cline is the first, in my opinion, and to some extent the best agentic software development agent. They're open source, which is a very good match with us. And they were probably one of the first ones who made AI-assisted software development possible. Of course, that applies to Java and other languages, but we are in the Java world. So one of the easiest applications, if you will, of this AI-assisted software development is to do modernization, which we did some internal projects on. Obviously, it understands your code base and in an agentic way goes and discovers things that it needs to do. Like I said, because it's an agent, it's goal-oriented, as opposed to saying, hey, I'll complete this method for me or auto-complete me. It's more about, well, I want to refactor this class, just go figure out what needs to be done. And if it discovers that, by the way, this is almost broken, it will actually suggest, well, this refactor will give you these benefits, but really you have to re-architect your software. It doesn't work like that. And that's kind of super useful. And then with the features that it offers you, like skills and the context management, you can adapt it to basically the Java system. So like I said, it's just autocomplete, it's end-to-end workflow and context management is built to that. It has multiple levels of context management, including rules, skills, workflow, and memory. Some of the concepts, by the way, that we discuss here, even if you're from a codex shop or something like that, this applies to you. This is how AI agents work. But we have Saoud here, and we're going to talk about how Cline's opinion is about it. And I think they're really good at understanding and kind of leading the way on that. The fundamental part of a agent is really how to manage the context so that the LLM gets the job done. In other words, if the LLM is the brain, the agent is the harness around it that makes it possible. And with that, I'm going to pass it on to Saoud, who's going to talk about how Cline approaches that. Over to you, Saoud.
Do any of you guys remember the painful days of like copying and pasting code from your IDE to ChatGPT and trying to tell it what you're dealing with, and then having to copy stuff from ChatGPT to your IDE and build things and hope things would work? Can I get like a raise of hands for people that like experienced that pain? Okay, yeah, it was awful. And at the time, the models were trained for like a sort of like Q&A format where you would ask a question and would give an answer. It didn't really have the capability to do things autonomously on its own until Claude 3.5 Sonnet came out. And so that's around the time when they gave the model more of a capability of understanding that it could do things on its own and it didn't need as much hand-holding. And they trained it in a way where it wasn't so much for this Q&A format as much as it was the sort of like successive requests and step-by-step, breaking a task down and accomplishing work on its own. So that's where Cline kind of came in. This new model came out and it was way more capable than a Q&A bot. And I was dealing with a lot of pain of having to copy and paste stuff between ChatGPT and an IDE. And learning more about how they train the model and how it works, I realized that it's essentially just autocomplete, where you give it, the first half of a story and it kind of completes the story. And so Cline really is just telling a story to the model that here's a developer, here's the code that they're looking at, here's some terminal output in their IDE, here's some debugger linter errors, here's their operating system, and just giving it this narrative of your context, and then letting it almost complete the story by answering your question about the code or completing a task on its own, saving you the pain and trouble of having to like switch back and forth between two different applications. So during the early days of Cline, a lot of it was putting this like very general purpose agent out there just to kind of see how our users would use it. It was like very flexible. At the time, it was basically just an input field, and you would ask it to do something and you would just watch it call tools and work. And eventually we saw how people would do this thing and incorporate users' workflows into the product itself. And so one of the things we saw our users do was they would have a markdown file in their project that they would have the agent read anytime they started a task. So usually in this markdown file, they would have rules. So for example, architecture guidelines, coding standards, just conventions, so that anytime they started a task, they wouldn't have to like put that into their first prompt again. Eventually, they started stuffing way more stuff into these markdown files, like how to do migrations and QA checklists and deployment instructions, things that although are might be useful, it's not relevant to every task you give it. And so every new task you would start with the agent would just have all this irrelevant context that ultimately just dilutes its ability. So eventually the ecosystem kind of consolidated around this concept of skills, where instead of loading these markdown instructions in with each request, it would be loaded in on demand. So just to explain skills a little bit, for anyone that haven't used it, they're essentially markdown files that get loaded into your conversation with the agent on demand. So you give a skill like a description, like use this skill when the user wants to migrate Java code, and then the model dynamically loads that in when it feels that it needs to for the conversation. So why does this sort of context engineering matter? This is a chart showing how performance drops off the further along the context window you go. So this is for GPT 5.4, and these are benchmark results from OpenAI themselves. And so you'll see that like at around 8 to 10,000 tokens, you're performing at almost 100%, at 97%. And then when you get further along at over 50,000 tokens, you see this drop off, and around 500,000 tokens to 1 million tokens, you have a 37% performance, like almost a third of how much you could get if you were just a little bit more intentional with how you were working with the model and being like very specific with the context you give it. And so this, I hope this gives like some idea of like, if you were to stuff way too many instructions into these markdown rules files, you ultimately are always operating in this like, 79 to 37% performance area, versus if you let the model dynamically load in these skills on demand, then you're going to be operating at a much smaller context usage and getting much better results from the model. So here's kind of an anatomy of a Cline request. This is essentially what an API request to the model looks like, where you have a system prompt, you are Cline, a coding assistant, and then we give it some information about how it's operating in the IDE, the user's operating system, stuff like that. Then we have a list of the tools that it has available. And then underneath the tools schema, we have available skills that it can load in on demand along with what the description of that skill is. So for example, here's a good Java migration skill where the model might need to read this additional instructions in to know about deprecated APIs, for example, that it's not trained on or doesn't have as much knowledge about. So the first request has the system prompt and the user's message. So the user said, migrate this project from Java 11 to 21. So that API request goes through, the model thinks about it and comes back and has this response where it decided to use the load skill tool for the Java migration skill. And then the agent application responds back to the model with the Java migration skill. And at that point, it has the user's task, migrate this project from Java 11 to 21, and this very large markdown instruction of how to do Java migration, along with references to, for example, scripts or additional markdown files that might be useful for something like this. And then it goes on and does the work. And so you can imagine if you asked it a task to create a landing page or something, it'd be very wasteful if it had all the Java migration instructions loaded in for something that's totally irrelevant. And that about covers my part. Skills are I wanted to cover one more thing before I let Mahdi take over. Skills are a sort of primitive in this space. They don't only apply to Cline. And so any skills that you create in Cline can be used in any of the other coding agents as well. Skills are kind of this standard for working with these coding agents. And they ultimately lead to much better performance. So before I hand over to Mahdi, does anybody have any questions about anything that I covered?
Does Cline have its own?
Does Cline have like an interface for skills?
Yeah, or what's available?
Mm-hmm. So Cline is a VS Code extension. It's a JetBrains plugin. It is a terminal application. So you can use it wherever you're working. And it's essentially just, you could think of it as like ChatGPT in your IDE. And we have a interface for being able to like create and manage and be able to enforce skills within your organizations as well. The minimum requirements, it's as long as you are working on a machine that can run VS Code or JetBrains, then you should be able to use it.
And since it's Oracle, we have, kind of like you have an SSH to a box for things to work, stuff like that, all works out of the box. Mm-hmm. But fundamentally, Cline, originally started from a VS Code. That's how we started using it, but now have expanded to the whole ecosystem, including having IntelliJ and the V2, which I think you guys relatively recently released, and now is ACP compatible. So basically the agentic part versus the part that interacts with IDE are relatively separated out. So let's say you have your favorite stuff, like let's say Z as your IDE, right? But you also want to use Cline. Now you can kind of marry them together if that's what you wish.
Yes. What is it? Yeah, so they all, under the hood, mostly work the same. They're essentially just an agentic harness that the model uses to intelligently load in context and do like complex tasks. Cline is open source. Cline is in VS Code and JetBrains in the terminal. And We also have things like an MCP marketplace and are coming out with a skills marketplace and basically tapping into our open source community to help us like grow an ecosystem around the product as well. And then we've also spent a lot of time working on putting things like enterprise guardrails and things so that when you do bring Cline into a large team, that you can enforce that the agent follows certain rules and skills and works within the confines of like how your team operates. Yeah.
That's a fantastic question, probably for a different talk, because I literally have a talk actually on this in a separate thing. But like how these agentic harnesses slightly differ in terms of their opinion about how to, almost like how models have evolved. Like some models are from first principles, let's say anthropic models. Some are just more data-driven and different. But those nuances do show themselves. But by and large, understanding how the structure of the new world of AI-assisted software development works is, I think, almost like basic literacy at this point for all of us in this software business.
All right. Okay. Thank you, everybody.
Cool. Thanks. So, thank you, Saoud. So let's keep going on. So now that you kind of get the idea of how you're going to approach that, how to basically make your agent, in this particular case, Cline, understand. Now we're going to talk about how we have built a skill. And fundamentally, the skill is going to encapsulate the migration knowledge. I talked about what are the sources of truth for that. We talked about that exactly because of this, because your first source of truth about migration is that what Java team believes you should be migrating and how you should be migrating. What are the most important language structures, features, what have you, to start with. It covers APIs, dependencies, configs, and whatnot. And then it guides the upgrades, step by step. Typically, teams, when they do that, almost like humans, it's like, okay, we're going to go to 25. Does all of our dependencies actually already have a 25 version? That by itself seems to be a big question. And I would expect this to be less and less of an issue when these AI agents are actually in charge of like upgrading your dependencies. And whatever coding agent is out there is going to basically have cut different versions of that dependency. So you will not be just locked into your old dependency, locked to an old version because of that. The good part about this is, skills almost like act like rules that get loaded on demand. The same way that Rizwan was talking about, Saoud was talking about. But the way that we've approached it, and I think you guys have to kind of do the same thing, is that you can start from a generic, I want to upgrade, and probably like Java team at some point will release something similar to this, that what we internally have, that this is the skill that is for a typical Java application, how would you use? And you would just download this skill and kind of use it. You can. But guess what? These skills are fundamentally nothing beyond a set of files, markdown files, and stuff like that. It's almost like the manual that you give your engineer to read and then do implement it, except that engineer doesn't need to eat any sleep. He's just going to use NVIDIA GPUs to generate tokens and go about his business, and hopefully do it faster, right? But oftentimes, every organization has built their own kind of way of song and dance around how they have used their platform, even if they might have been using standard frameworks like, say, Dropviz or Spring Boot, or Heliden, things that Oracle uses. And so the good part is that you can literally add those as extra rules on top of the system. And oftentimes, and Cline implements it like that, other places you can see it, is that you can have these skills implemented at every single repo level. So if you have done something that's specific and you want your coding agent to keep track of that fact, for example, do not touch this module because someone did it and nobody wants to touch it, you can literally put those rules in if you want to. So this layered approach of how to customize to the domain level, from the internal rules and dependency management all the ways down to specific tooling that's used for validation. When I work, for example, with NetSuite team, they have built their stack on top of Java so heavily that it almost looks its own kind of system. And their key point was that, okay, when I tell my agent to upgrade this stuff, we may not use Maven vanilla to say, is the build successful or not? They have their own set of tooling. If they want to kind of run those stuff, you literally have to just have a CLI, which of course, hopefully you have on your machine if you're working with that repo. And also kind of put that in terms of, this is how I validate. And the amazing part is that these are all natural language. Like this is not like some language or DSL or something like that that you have to adopt. You basically explain the same way that you would put in your runbook. Hopefully you already have it, by the way, into a part of your skill that says this is how validation takes place, and if the output passes, then you're good, for example, for this stage of that. And one thing that we particularly use heavily is those assumptions about the build environment. Let's say, we are in OCI, we kind of like assume in this region, in that like environment, all that kind of stuff. Sometimes when you don't offer that, like no agent would know off of the code, because their view is all about like, where I'm building the code. But oftentimes if you have to like ship it and test it in a CI/CD system or something like that, those assumptions may not exist and would kind of like challenge you. So kind of like the end-to-end story is that when you discover the current state, let's say this is Java version X, you plan an upgrade path. That is how the agent figures out, do I have an actually skill that says, specifically go from Java version X to Java version Y, or the skill is built, a little bit more generally. So it plans basically the upgrade path. And the good part about these kind of agentic systems, particularly Cline, is that it actually tells you ahead of time, this is what I'm going to do. Does it sound good, or it's just like a crazy idea? And you can adjust and adapt to it. So basically you are now suddenly like a senior engineer, if you will, dealing with this, let's say a junior engineer that is your agent, that is kind of planning the work and going forward. And you can live kind of look at that. You can analyze the impact and stuff like this and finally, validate that. So on the discover phase, literally the workflow that hopefully will come shows, you detect the Java version, you of course identify dependencies, and then go search the web for if there is a better version of, like the proper version of that is available, understand the frameworks and stuff like that, and fundamentally kind of discover what I need to do for the upgrade to happen. That includes, by the way, going through your files, for example, and see if the older structure has been used and some of these classes that are deprecated should not exist anymore post upgrade. And literally that translates into rewriting a piece of code. Again, that agent does that for you already and creates like those diffs that stop using, for example, if the else use the switch, for example. On the plan side, then the information from the JEPs come into picture, where it uses what are the things I need to change moving forward, and plan basically give you the plan for this is the upgrade path I'm thinking. Now that's much more detailed. It's not like a high level that I'm giving you the plan. It's more of I'm going to touch this file, I'm going to like edit this stuff about it, and so on and so forth. And fundamentally, like, you can look at basically the output of it and see, what parts of that is, doing it for deprecated APIs, for example, remove features, all that kind of stuff. And something that used to be very hard now has become very easy. It's the actual refactoring of that. It used to be like someone mentioned Cursor. When Cursor had multi-file edit, everybody was like, wow, this is such a new feature. Now you don't see, like, you don't ever count how many files you actually edited. Because like the only thing that you care about is like, what's the diff? 1 file or 500 files, you don't care. You can basically almost like review the code change, however that's done. And that's kind of like, where the refactoring comes in. So when I say refactoring, it's less of refactoring the code, more of like changing the code however is needed to be done to the actual execution of the plan. This is like nitty-gritty at the code level. This line changes, this dependency gets updated. And then the last part is modernize. Oftentimes, the workflows that we have built work like this. First, do the dependency upgrades so that we kind of know things have not broken. Then we go about looking at the new features that are coming as part of the language, or the new version of the language, and then use those features to at least like get the benefits of the modernization. So on the validation side of things, once all of these code changes happened, very often, even if you're a normal engineer, you probably have seen it. It will not build. Your first Maven build just like fails. Hopefully, at least there would not be syntax error, but guess what? Because these LLMs actually can produce, like used to at least produce like sometimes code that had syntactic errors, like they would error. And believe it or not, like Agentic actually helps with that, because like when it fails, it looks at the error, it actually goes and fails it. So that's the good part, in the sense that even if your LLM used to be crappy, the output will still converge to something useful. So of course you want to build success, you want your tests to pass, and then you want to validate the behavior. So it will probably not immediately help you if you don't have good test coverage, particularly on the integration side of things. But guess what? We are talking about migration. You can use this agentic coding to actually increase your coverage on the integration tests as well. And finally, you have to ensure stability. In our case, when we have rigged our coding agents, we allow them to kind of deploy to lower environments so that we don't even have to deal with this stuff. Particularly Cline and other agentic codes, they can like run bash for you. So then the sky is the limit, as long as they know how to like, write, for example, write OCI commands and so on and so forth. So to bring it back home, what you really get out of this is basically faster upgrades, higher confidence in terms of like the quality of things, and you make basically your applications future ready. And going back, why it matters? Because we're a Java community, we want like you guys to use the latest version of Java. We're very excited about it, and we want to unblock you to actually benefit from this. Coming back to the whole thing, this has been a collaboration between Java team, who's been hosting this conference, have invited me from the Codesys team, and of course, Cline team, who have been graciously accepting our invitation to come and talk about their coding agents with us. So, if Oracle Codesys is not just internal, talk to your, who works with you with Oracle. There is a beta version of that is available for teams who want to try it. And in terms of takeaways, of course, upgrades are knowledge intensive, but you can do it with your coding agent. You don't have to wait until until your engineers kind of like catch up with the new spec and stuff like that. You can just give it to your agents. And with that, I conclude. Thank you so much. I think we have a little bit of time for questions and answers. So let's open it up. It highly depends. For the Java upgrades, for the most part, it's actually a good choice. Like the one that we have right now internally is actually mostly Markdown, right? Because the rest of the system are the Java ecosystem. Like you can run JFR, you can like every Java tooling that you're familiar with. Guess what? All these LLMs know how to use them, probably better than me at least. And so I don't need to have a specific tooling or scripts and stuff like that. Now, if you have built an ecosystem, if you basically have your own rituals encoded into some shell scripts or what have you, definitely in the Markdown, you tell your agent that this is how we validate as opposed to like the standard validation. Like if you ask any LLM right now, and coding agent of course, that validate my project, it does maybe validate. Like that's what it does, like out of the box. If it's a lot, I mean, sometimes a little bit smarter looks at, if you're using Maven versus Gradle versus like that, but like an execute start command. But basically, Cline, for example, just literally that's okay. It's a Gradle project. I'm gonna this. Do you give me access to shell? You say yes. You can question if that's a great idea because like basically it's running commands on behalf of you. But once you grant that access, it basically goes, runs, looks at the results, if it was successful, not successful, and kind of iterates over that. But for migrations, the first implementation we have had is actually, for the most part, what a runbook would look like for a human. It doesn't have to be like crazy precise or something like that. That's almost like a shell script. It's very much step one is look at the dependencies. Step two, look at this kind of stuff. And because all of your models and agents have access to web, for example, they can web search and see if the Maven repos, for example, have a version of the dependency that you're asking for. In our particular case, talking about the layered approach, is that we don't actually manage our dependencies, one by one. We have like some teams who's in charge of actually publishing bombs. So typically what we do is that, similar to the engineer, you're like, go find the bomb that is compatible with the version I'm going to go upgrade to. And that team is responsible for managing all the dependencies for that particular version upgrade. But then they use also the coding agent to upgrade this version set and things like that. So it gets a little bit for enterprise situations, gets a little bit more kind of involved, but it's more of like how your organization manages this stuff. If there is one central place who's in charge of dependencies and then everybody kind of benefits from them, or vice versa. But for the most part, give or take 90% of that is just empty files.
So you feel like the idea of using tools like overview-write kind of becomes pointless?
Not exactly. So it's almost like, there is this thing, MCP is dead, long live bash, right? You're not there. I think these are the tools in your toolbox. Whenever I'm advising teams, it's like, if you have a deterministic tool that gives you really good signal about how things should work, and particularly tools that are open source, that your LLMs understand their output, 100% use them, right? But do not go just shoehorn, for example, MCP or some skill on top of something that trivially is known. You don't have to have a skill for everything. It's not like the new plugin. It's not like APIs are dead, long live MCP. Not really. right? If you're doing that, it's probably not super productive because at this point, like, you of course, you're feel free to like build your own tools and whatnot. But tools almost like similar to how we encapsulate stuff, like back to the principles, how you write a Java class, what a class purpose is, like what are these methods and stuff like that. Think about that system structure within your skills and these constructs that we're talking. Some things are better to end up in tools. Some of them are better to be as rules because they apply everywhere. And some are specific purpose rules or workflows that you will leverage only, once in a blue moon, hopefully. And that's kind of like goes to the skills side of things. Awesome. No more questions? Quickly show of hands, how many of you guys have used Cline? Nice. How many have used any agentic coding? Okay. You have a little bit to go, but hopefully next talk, everybody has used it and you guys will come challenge me if anybody is running Gastown versus not. If you have not heard of Gastown, go look up internet. And with that, we conclude. Thank you so much, everyone.